Yeah, so this is joint work with Sarah Fry, Lisa Marquand, and Shucheng Chen. And I'm really glad for Sarah's talk this morning because, first of all, I think it was a delight, as it always is, to hear about cubic fourfolds, but also she's introduced the main characters already that I want to talk about. And I just want to show you sort of a cute story that popped up in one of our projects from a couple of years ago that we then explored in a more recent paper. So just to tell you who the characters are again, X is going to be a smooth cubic hypersurface of dimension n. And then F is the Fano variety of lines on X. So this is also going to be a smooth variety, and then you can just compute its dimension. So in Sarah's talk, she was looking at cubic fourfolds, and then the Fano variety of lines is a hyperkähler fourfold. And that's the example I want to zoom in on it in a minute. But maybe just to give you the most down-to-earth example, which I also have stolen from Wikipedia, but did a worse job of attributing authorship than the previous presenters. But I think I contribute enough plant photos to the Wikipedia project to be forgiven. So if you have a cubic surface, then the Fano variety is just 27 points, right? And this was my one attempt, I'll disclose, of using ChatGPT to make a picture with 27 dots on it, and I just couldn't do it. So instead, I typed 27 periods, and there's our Fano variety of lines. So then here's the big question, does F determine X? And I guess if we go back to this example of the cubic surface, you can see like definitely not in general, because any two cubic surfaces have the same Fano variety of lines, just 27 points, right? But two cubic surfaces need not be the same. So let's see, just by varying n in dimension 2, the answer is no, very far from being true. And then in dimension 3, it turns out the answer is yes. If you have two cubic threefolds with the same Fano variety of lines, then those two cubic threefolds are isomorphic. And then in dimension greater than or equal to 5, also the answer is yes. And then you can see I skipped 4 and left a big gap there because that's what I want to talk about. So we were curious about 4, and the answer is sort of an almost. So let me say what I mean by this. If you have a very general cubic fourfold, then the Fano variety of lines is a hyperkähler fourfold with Picard rank 1, and it does uniquely determine the cubic fourfold. So you can recover the cubic fourfold from its Fano variety of lines. But in higher Picard rank, you sort of can't make any proof work. And so I guess there was this math overflow question, which is exactly the same thing that I've just summarized, asked in 2018, which is sort of summarizing all other dimensions. And then the answers are all kind of responding to the n equals 4 case, and everybody was hemming and hawing because it's kind of like true in general, and then the proof doesn't work in higher Picard rank. So, okay, but there were no examples that we knew of. So then we come up with this example in discriminant 20. So in the moduli space of cubic fourfolds, there's a divisor parametrizing the cubic fourfolds containing a Veronese surface. And these are called cubic fourfolds of discriminant 20. And Fan and Lai in 2020 proved that if you have a cubic fourfold X of discriminant 20, then there's exactly one other. Okay, and let me say very general cubic fourfold of discriminant 20. Then there's exactly one other cubic fourfold also of discriminant 20, which we can call X prime, that is a Fourier-Mukai partner of X. So that has something to do with the semi-orthogonal decomposition of the derived category. And also X and X prime are birational. So it's kind of a beautiful example. And so I'm going to let F be the Fano variety of lines on X, and then F prime be the Fano variety of lines on its Fourier-Mukai partner, described by Fan and Lai. And then with Sarah Fry and Lisa Marquand, we proved that F and F prime are isomorphic. So this kind of gives a negative answer. No, the Fano variety of lines does not determine the cubic fourfold in general. Let's see, when did I start? I wasn't paying attention. Have I already gone 5 minutes? Okay, yeah, great. So if you want to ask about how this works, then I'm happy to say afterward. Then we found kind of a similar example, which is a cubic fourfold containing a pair of cubic scrolls that intersect in 5 points, which we call the non-syzygetic pair. And we did some sort of analysis of the movable cone of its Fano variety of lines. This is kind of a chamber decomposition of positive cone, and then there's a birational automorphism group acting on it, and the orbits correspond to birational models. And we just found, so here's the Fano variety of lines. We found some other chamber that corresponded also to the Fano variety of lines on some other cubic fourfold. And these two Fano varieties are birational, but not isomorphic. So in particular, the cubic fourfold that has this Fano variety of lines can't possibly be isomorphic to X. Okay, and then we were able to prove, in fact, that those two cubic fourfolds were still somehow related. They're birationally equivalent, just like in the discriminant 20 example. So kind of what I want to advertise here is this conjecture that we made. If you have two cubic fourfolds and their Fano varieties of lines are birationally equivalent, which could also even be as strong as isomorphic, then X and X prime are birationally equivalent. So there should be kind of a really strong relationship between the cubics. And then here's kind of an image showing how this conjecture ties in with other possible conjectures about relationships between cubics. Okay, that's all I had to say. Sorry for going over. Thanks.